now that we know how to multiply a monomial times a polynomial, we want to take this a little bit further. We're going to look at some more specifics. Okay, so now let's look at what happens if we do a binomial times a binomial. Okay, that two terms, binomial means two. So today we're going to be multiplying something with two terms, maybe like x plus 2, times something else with two terms. So maybe a 2x plus 7. Now, multiplying binomials is something that has an acronym that goes with it, similar to PEMDAS, right? Lots of us, when we think order of operations, what we really think of is the phrase PEMDAS, which is an acronym, right? It stands for each sort of piece along the way. This has something similar that is called FOIL. Okay, FOIL is an acronym. It stands for first, outside, inside, last. And it's sort of a trick that people came up with to help you memorize what to multiply when. Okay, it is stuck so well that you'll often hear people use this as a verb, talking about the problem. They'll say, FOIL these two problems. Okay, we're not actually going to go through the foiling process, this FOIL, because that only works with a binomial times a binomial. If we know how to distribute and we learn how to multiply these, we're then going to be able to apply that to any situation with multiplication. So while we might hear the word FOIL, and it's probably important that we recognize that that's talking about multiplying these two things, I'm not specifically going to tie it to those acronyms, first, outside, inside, last. Instead, what we're going to do is we're going to look at this first binomial, and we're going to break it up into its two separate terms. Okay, so the first term is x. I'm going to ignore the fact that there's a plus 2 here, and I'm just going to start distributing like I did with a monomial times a polynomial. Okay, so when I distribute here, I'm going to say x times 2x. Okay, x times 2x, right? We add the exponents. So that's going to give me a 2x squared, right? 1 plus 1 gives me that 2. I'm still distributing that x, so now I'm going to take an x times that positive 7, which will give me a positive 7x. Okay, then I'm going to switch. So I'm going to uncover that positive 2 and ignore the x to the first, right? I need to leave this addition sign uncovered because it's telling me that this 2 is positive. If this was a subtraction sign, then I would need to be dealing with a negative. Okay, so I'm going to start distributing my 2. So 2 times 2x is going to give me a 4x. Okay, 4x is a like term with 7x. So while you could put your positive 4x over here and you could keep writing horizontally, a lot of the times my students like to recognize that because 7x is an x to the first power and 4x has an x to the first power, these are like terms, and so they sort of stack them on top of each other. Okay, we'll keep distributing. 2 times 7 is going to give me a positive 14. That's not a like term to anything else I have here, so I'm just going to write it out to the right over by itself. Once I've done that, now I'm going to go back to my adding and subtracting polynomials. I'm going to combine my like terms. So since I wrote this stacked, right, this is nice and neat, everything comes straight down. 2x squared has nothing to combine with. 7x plus 4x gives me an 11x. And then a 14. So our final answer will be 2x squared plus 11x plus 14. Okay, so now numbers can show up in different places. We might have some negatives to deal with, but the process is always going to be the same. So maybe we have 6y minus 8 times a 2y minus 4. So if we start distributing, okay, if we go here, right, I'm ignoring that second term. 6y times 2y will give me a 12y squared. 6y times a negative 4 will give me a negative 24y. Okay, so now that I've distributed that 6y to both terms, I'm going to switch. This is subtracting 8, so this is a negative 8 that I need to distribute. So a negative 8 times a 2y will give me a negative 16y. And a negative 8 and a negative 4 will give me a positive 32. Again, now I already have my like terms matched, so I can go straight down to combine like terms. So my 12y squared is just coming straight down. If you needed to, you could use a calculator to add these together. Okay, but if we do a negative 24 and a negative 16, that will give us a negative 40y. And then our 32 comes straight down. Okay, we can have some other unique situations that might happen. If we look at this problem, we still have a binomial times a binomial, but these are what we call conjugates. They look exactly the same, but one has addition and one has subtraction. We are going to multiply this the same way we have in those past two examples, but a little bit of a unique situation is going to show up when we go to combine like terms. So we're going to ignore this piece. We're going to take 3w times 3w, which will give us a 9w squared. Right? These each have an exponent of 1. When I add those, that's where my 2 comes from. I'll take my 3w times a negative 4, which will give me a negative 12w. Okay, now I'm going to switch, and I'm going to distribute my other one. Sorry, I smudged the paper there. Okay, so now we'll take 4 times 3w, which will give us a positive 12w. Again, these are like terms. And a 4 times a negative 4, which will give us a negative 16. Now when we go to combine like terms, our 9w squared comes straight down. But a negative 12w and a positive 12w, they just cancel out. And the same way that we said this with adding and subtracting polynomials, these just become a 0w, and we don't write that down. There's nothing there, so those just cancel each other out. And so our final answer will just be 9w squared minus 16. Now, it doesn't always have to be the case that terms can be combined. Okay, so maybe if we have 4x squared plus 2x, and we're going to multiply that times 3x plus 7. Okay, again, we're still distributing, still passing this out. So 4x squared times 3x is going to give me a 12x to the third. 4x squared times 7 will give me a 28x squared. Okay, here will give me a 6x squared. So this one actually has combining, but they're squareds that will combine. Plus a 14x, right? 2x times 7. Again, when we add and subtract, we just keep the label the same. Okay, so we're going to get a 34x squared plus 14x. Okay, we could not stack anything here at all. We could have x's and y's. Okay, the process is the same though no matter what. The only other situation that's truly unique is if we have something called a binomial square. Sorry, I'm at the end of my paper, so I'm going to squeeze this in. So if we have something like 6y plus 4 squared. Okay, at this moment in time, it doesn't look like it, but this is still taking a binomial times a binomial. And the reason why is that an exponent of 2 says to multiply something by itself. So this really says to multiply 6y plus 4 times 6y plus 4. So we're going to write it out twice, and then again, go through the same process that we just did. Okay, that's the good news. Once you know the process, even though the problem might not have the same terms combining, it might have different exponents, the process is going to be the same. So we'll get 36y squared plus a 24y plus a 24y plus a 16. So after we combine like terms, our final answer will be 36y squared plus 48y plus 16. So go ahead and try the worksheet, and then when you're finished, watch the next video to make sure that you got the correct answers.